Hi, I'm Hélène, a PhD student at BAPEC. It's a real pleasure to present the research I conducted with Tommaso Ghilardi under the supervision of Professor Elisa Ferré and Dr. Oriol Smith. This research is about physical cognition and how real-time embodied experience affects high-level reasoning. Our successful interaction with the world relies on our ability to reason about action outcomes, and this involves reasoning about the physics of the world, such as gravity. Existing evidence does not clearly allow to distinguish between an innate versus an emergentist view on how humans learn the physics of the world. Our research aims to investigate how the real-time embodied experience contributes to physical reasoning. To address our research question, we created an environment which was new to participants by manipulating their embodied sense of gravity. The vestibular system plays a key role in providing gravity cues, and by using the galvanic vestibular stimulation, or GVS, which is well known to alter vestibular gravitational signaling, we can disrupt participants' gravity embodied experience. We tested participants in a computerized gravity-related reasoning task, the virtual tool use, which was developed by Hélène and colleagues. This task is not related to motor action, but is a more high-level cognitive task where participants have to mentally predict the outcome of using a tool to reach a goal. We use a within-subject design, with each participant solving games under the GVS stimulation or the sham or control stimulation in a counterbalance order. Our hypothesis was that participants would be performing better in the physical reasoning task with normal terrestrial gravity than when their embodied gravity experience is disrupted. We looked both at measures of performance, such as success rate or number of attempts, and at measures of strategies, such as distance between the location in the different attempts or tool switching between the different attempts. We also applied a cluster analysis to look at the strategies applied by participants under the two stimulation. Overall, we did not find a significant difference in performance between the GVS and the sham conditions. However, when we had a look at the game level, we found a few games for which GVS had a significant negative impact in performance, as you can see in this bar graph, and in strategy measures, as you can see in these bar graphs. These games were involving strong gravity-related predictions. Similarly, when we looked at the result of the cluster analysis, we found that participants applied different strategies when they played the games under the sham condition and the GVS conditions, as you can see in these pictures below. Overall, the findings of this research highlight that immediate embodied experience shapes humans' physical reasoning. Thank you very much for your attention. I look forward to discussing these findings further at the EPS meeting in January.